Hi and welcome to Chemistry 1. Here are our first few videos. Some of these I realize you're going to be pretty familiar with. Some of these you can sort of take or leave. Give them a chance. There may be some little details here that you need to pick up on that you haven't thought about, but this first video is on measurement, which you may say, well, I know how to measure things. I don't need this video. But give me a chance here and make sure that you're good with this information. This particular little video is going to focus more on units of measurement, and then we'll get into some other videos later on about accuracy and precision, which you may be familiar with, but you probably aren't familiar with significant figures. Usually when I ask students, it's the first of the year, they've never heard of significant figures. So that's going to be some of the focus of these few videos that we're going to do. But this one is more about just the measurements in general, particularly focusing on units. So if I take a measurement of something and I say, well, it's 20, what does that mean? That quantity of 20 really doesn't mean anything unless I have a unit that defines that. And so, it might be 20 centimeters, it might be $20, it might be 20 milliliters of acid. I have to have some defining something to tell me what it is that I'm measuring. And of course, those units of measurement give us a way to compare with other people who are doing the same kind of work. And hopefully I'm sure you do know because you've had good middle school teachers, that the units that we use in science are metric units. We don't use pounds and ounces and feet and yards and that sort of thing, inches. We use these metric units. And there are some standard metric units, and these are those standards. And actually they're based on a quantity of water. We won't worry about that. But your unit for length is a meter. In the lab, though, a meter is a pretty big distance. It's about a yard, if that helps you kind of visualize it. So we usually divide that into smaller increments like centimeters and millimeters. So I've got this standard unit, and then what we're going to encounter more often when we do lab work. For mass, the standard unit actually is the kilogram, and that's a little unusual because this word already has a prefix on it. We're going to talk about those prefixes a little bit. And a kilogram is about 2.5 pounds. That's a rough estimate. So in lab, we usually don't use amounts that are that large, so we're going to probably be using grams most of the time. And for volume, the standard metric unit is a liter. Again, that's a pretty large amount. You can think about a liter water bottle. Those are pretty common. So in lab, usually it's going to be the milliliter, which is prefixed here with milli, which means 1,000th of a liter. So you need to get into the habit of thinking about those metric units. Now, the good thing and the bad thing about the metric units is that we have to think about those conversions. They're really much easier than standard conversions because they work on powers of 10, but they get confusing, I realize, because it's just not something we're used to thinking about. So let's look at those prefixes here for just a minute. And again, you can find this kind of chart in lots of places. You can find it online, you can find it in textbooks. But if you want to take notes on this one, that's fine too. I'm going to lift up my camera here so you can see the whole thing. And then we'll kind of zoom in on parts of it. So you notice here in the middle we've got a base unit. That essentially is the unit without a prefix. So meter, liter, and gram are the common ones. We can put these prefixes in front of anything else. If we're measuring pressure, there's a unit called Pascal, and we'll talk about kilopascal sometimes. So it's not just those metric units that can use these. These are more universal than that. But from that base unit, if we're going up the scale the way I've got it drawn here, these are larger units. They're multiples of the base unit. And as we go down here, they're getting smaller and smaller. So these are fractions of the base unit. So let's look at the multiples here first real quickly and just point out a couple of things here. I'm going to get my camera settled back down. So here's the base unit. And I just stick a prefix in front of it. So my base unit might be the meter. And if I talk about a decameter, that's 10 meters. So it's 10 times longer than a meter. A hectometer, they'd probably say hectometer, is 100 meters. And the kilometer, which you've most likely heard of, is 1,000 meters. So our units are getting bigger and bigger and bigger and bigger as we work our way up the chart. So notice powers of 10, we're just adding a 0 with each step. Where it gets maybe just a teeny bit confusing is when you skip from something like kilo to mega. Here I have a name for each 0 that I add, times 10, times 100, times 1,000. But I go from 1,000 to a million here. There is no name for 10,000 or 100,000. It skips straight to a million. So if you're doing conversions, just don't forget those decimal places that come in between there. So mega means a million of whatever my base unit is, whether it's a meter. You see these a lot with computer storage. So it might be a byte, a kilobyte versus a megabyte. So that's a million. And then again, there's nothing for 10 million or 100 million. We skip up to a billion, which is giga. And it can go further than that into things like terabytes. But for what we're going to use, just these. That's all you really need to know. And some of these, of course, are more commonly used than others. You see kilo quite a bit. You see mega. But you don't see hecto and deca all that much in chemistry. And we'll look at how we convert with these in just a bit, but I wanted to introduce you to the words first. As we work our way down, we have the fractions of these. Our units are getting smaller. So a decigram, let's say, is a tenth of a gram. I'm dividing it into 10 smaller parts or 10 equal parts. A centimeter, that's probably something you're familiar with. That's 100 units, a hundredth of that meter. And a millimeter is 1,000. So just like the larger units, I have names for tenth, hundredth, and thousandth, but not for 10,000th or 100,000th. So I skip from milli to micro, which is a millionth. That'd be 10 millionth, 100 millionth. And then nano is a billionth of whatever unit it is, whether it's a gram or a meter or a liter. Then I have a 10 billionth and a 100 billionth. Then we get to pico, which is a trillionth of the base unit. And then we can skip 2 more spaces there. So what was that? Trillion, 10 trillionth, 100 trillionth. And then for femto, I get to a quadrillionth of whatever unit that was. And so realistically in chemistry, we talk about things that are at the nanometer scale or the picometer scale, even the femtometer scale. So the smaller units are kind of more important to us when we're talking about atoms than the larger ones. But I just wanted you to have some familiarity with these. They do have abbreviations that go with them. So giga is a capital G and mega is a capital M. So if it's a gigameter, you've got the G for giga and then M for meter. If it's a megaliter, you'd have the capital M for mega and the L for liter. Kilogram, K for kilo, G for gram. And so you'll see these pretty commonly. Hecta is just H, and again, just a blank, whatever goes with it. Deca is DA to differentiate it from deci, which is just D. And most of them are pretty simple that way. Deca, centa, milli. When we get to micro, I've already got a big M here for mega, a lowercase m for milli, and so I just wanted to show you this one. Micro is the Greek letter mu. It looks like this. It looks more like a U, but think about that being an M with kind of pointy tops there. And so that's your abbreviation. If you see that sort of strange looking critter there, that means micro. Nano is just an N. pico is P, and femto is F. And again, it'd be followed up by whatever abbreviation you need for your base unit, meter, gram, or liter, most commonly. So that's really it for this video. I just wanted to introduce you to the basic units there, and I'll post another video where I do some conversions if you need some review and some help with that. Something, again, I think you've probably seen before, but just might need a refresher. And if you don't, again, you can feel free to skip it or look up another video online if you'd rather. So that's it for this video. I'll talk to you soon.